Today we are going to talk about calorimetry and its application in the real world. At first glance, this concept may seem like an isolated chemistry concept, but in actuality it has many real-life applications. Before getting into a sample problem, let's take a closer look at what calorimetry is.
According to the physics classroom, calorimetry is a science associated with determining the changes in energy of a system by measuring the heat exchange with the surroundings. To summarize, calorimetry is a measurement of quantity of heat exchange.
To help us better understand this concept, it's important to know how this applies in real life situations. For example, it can be used to determine the calories in the food that you consume. It can also measure the thermal efficiency of a heat engine, as well as used in chemical plants and laboratories to make sure that various heating and cooling systems can withstand heat changes. This is all happening around us all the time. Here is an equation used in all of these instances. That equation is Q equals M times C times delta T. The Q in the equation is the heat absorbed, the M is the mass of water, C is the specific heat of water, and delta T is the change in heat, which is temperature final minus temperature initial.
A real-life problem would be how much energy was released by burning a slice of pizza to heat 2,000 grams of H2O. Upon burning the pizza, the temperature of the water rose from 30 degrees Celsius to 166 degrees Celsius. We already know that the formula we use to solve a calorimetry problem is Q equals M times C times delta T. So let's plug in the information we have. We were given M, which is 2,000 grams of water. The specific heat of water is 1 calorie over grams times degrees Celsius. The information can be Googled and delta T we get by subtracting our final temperature minus our initial temperature. In this case, our final was 166 degrees Celsius and our initial was 30 degrees Celsius, which makes our delta T 136 degrees Celsius. Now we just go ahead and add the final bit into our formula. Multiply all of our knowns together and then solve for Q. You see now that Q equals 272,000 calories, but we want to know how many food calories, so we will have to use stoichiometry to get that answer. 1,000 calories equals 1 food calorie, so all we have to do is to divide the answer we solved for Q by 1,000, which is again 272,000 divided by 1,000, which equals 272 calories. So we now know that the pizza you ate had 272 calories, which is the information you might find on the nutrition label.